Boom. Hello and welcome back to Calculus 1, section 4.4 on graphing functions. It's going to be a two-part lecture because there is lunch in between, right? So let's take a look at the shopping list of things, of calculations that we need to do to graph a function by hand. Now, I'm not talking about graphing x squared and x cubed or square root of x, those that you memorized. I'm talking about square root of ln x squared, right? Or sine squared of 3x plus 1, right? So stuff that you would definitely reach for your graphing utility or go to Desmos, right, and graph. Why do we want this? Because you guys want to be indispensable, right? You know, if the solar flare hits, all the technology is gone, right? So who are the most important people on the planet in that case, right? Those who can graph functions by hand, right? That's it. So that's why we learn all of this. You either like that story, or we can go, you are stranded on a desert island, cell phone batteries out, you did not bring your TI-83 because you think you're not going to need it, right? Wilson is gone, you have nothing else to do, you want to create a shelter, right? You need to graph a function, and all you have is a stick in the sand, so here we go. What is the shopping list of things? The list. Number one, domain. As I mentioned before, you do not want to do calculations in regions that are completely unnecessary for a function, right? Square root of x starts at 0, goes to positive infinity. Do you compute at -3? No, right? So we want to know the domain so that when we do partitioning and we do all the other calculations, we are not working in the regions and we're not wasting time on calculations in the regions that are going to give us complex values and things that we just don't need, or infinities. Number two, little bit of elementary algebra. X and y intercept. You get these when you set x and y to 0, and so on. That's that. Number three, asymptotes. So this is pre-calculus and calculus. You have three flavors, right? Chocolate, vanilla, and strawberry. I mean, vertical asymptote, va. Horizontal asymptote, ha. And slant asymptote, sa. So those are the three types of asymptotes that you guys learned. And you know that this is 2.4 and these two are 2.5. If you need to do the limits and stuff, right, you do it. Usually it's obvious, so yeah. Number four, find f prime and f double prime. So you need these derivatives because number 5 is the first derivative test. Number 6 is the second derivative test. Now, first derivative test will also give min-max, right? So we have a whole bunch of these things, right? We have domain, we have x-intercept, y-intercept, we have asymptotes to guide which way to draw the functions, and then we also have the first and the second derivative tests that will give us increase, decrease, min, max, so the entire shopping list of things. After the first and second derivative test, number 7, we can look at the symmetry. Usually we never use this. Number 8, if we have to, because sometimes all of these calculations end up being very skimpy and you don't get much information. Then you have to resort to your middle school method, which is calculate additional points. You pick x equals to 3, x equals to 5, x equals to -1, right? And then just snake the function through those points. So calculate additional points, just if needed, okay? Don't make it a priority in life. And then number 9, finally graph and win. That's the right. That's it. So let's take a look at an example of this, right? We'll take something that it's nice and user-friendly, like a polynomial, let's say. So either one of these, they're all cool. How about problem 20? Let's say graph by hand, and then after lunch we'll do more. So x to the 4 plus 4x cubed, right? See, nice and simple, right? Nothing too complicated, like let's say social justice, for instance. Plain vanilla. What are all of our, first of all, domain, number 1, domain. Well, this is polynomial. And if it's polynomial, hopefully you learned, right, that domain is all real numbers. So negative infinity to positive infinity. You can also write that, or you can write the double bar R. So whatever makes you happy, right? Well, happiness is our primary concern. United Airlines, good. Number 2, we have the x-intercept, y-intercept. So for x-intercept, set y equal to 0. So we have x to the 4 plus 4x cubed equals to 0. X cubed and then x plus 4 equal to 0. X equals 0, x equals negative 4. I have 2 x-intercepts, and so these are x-intercepts, but then this one is also at the same time a y-intercept. You can only have one y-intercept because it's a function, right? And 0, 0, right, is on both lines. So anytime you have a 0, 0 for x-intercept, it's immediately for the y-intercept as well. Number 3 is asymptotes. Nova hasa, right? Because polynomials do not have any type of an asymptote, right? So vertical asymptote, horizontal asymptote, slant asymptote, none of them, right? Number 4, first derivative. All right, so that will be 4x cubed plus 12x squared. And then we also need a second derivative because we'll have the second derivative test, which is 12x cubed plus 24x. Great. That's what I said. Please pay attention. Thank you. What do you do like every Saturday and every Monday and every Tuesday? I need a teaching assistant. So now 5. First derivative test. We take our calculation up there for derivative and we set it equal to 0 to find the critical numbers, critical points, min, max, and all of that stuff. So we factor out 4x squared, and what's left is x plus 3. We have x equals 0 from the first and x equals negative 3 from the second when you set each one to 0. And these are our crit numbers. So now we do our partition, negative infinity, negative 3, 0, positive infinity, and we pick test points, negative 4, negative 1, and 1. We do the first derivative test, f prime at -4. 4 times -4 cubed plus 12 times -4 squared. -4 cubed is a lot, and it's negative. And then you have to multiply it by 4, so it's really a lot. If you take a look at this, it has 4 4s, right? And this one over here has 2 4s and a 3. So this is bigger, and it's negative. And this is smaller, and it's positive. So negative number that is bigger plus a smaller positive number is going to be negative. Again, you can punch all of these things in your calculator and get exactly to the 12th decimal, right? But we don't care about the numbers. We just care if they're, you know, positive or negative. So if you can do the analysis on the side, there's no reason to suffer. 4 times -1 cubed plus 12 times -1 squared, that's going to be -4 plus 12, that's 8. That was a stretch, right? Calculate 0, and we have increase. The last one is calculation at 1, which is 4 times 1 cubed plus 12 times 1 squared. That's all positive, right? So just something is terribly wrong over here. Something is terribly, terribly wrong over here. This is a polynomial and they have to alternate. Each polynomial, x squared, x cubed, x to the 4th, x to the 5th, they all alternate. Increase, decrease, increase, decrease, increase. You cannot have 2 consecutive arrows for polynomials. No way. So now, what's wrong? Something is definitely wrong. The derivative, x to the 4th is 4x cubed plus 12x squared. The derivative is 12x squared plus 24x. Factor out x squared, you get the 4x squared, and you get x plus 3. You get a -3. You get x, 0. Nice. Now, -4, plug -4 in the derivative. 4, -4 plus 12, -4. This is positive, and this is going to be a negative, but it's a bigger negative because it has 4 4s, and this has 2 4s and a 3. So it wins, and it's that. Good. This one is $20 a guess right there. -1 cubed, that's -4, plus 12, it's +8, larger than. Great. When I plug in test point 1, it's 4. What is going on over here? Huh. Okay. I give up, and here's why. The calculation never lies. There's the graph right there. It is actually true. It's the concavity that will change. It's late for cookies somewhere. So, need all of that extra power. Number 6, second derivative. Oh, by the way, I don't write the answer or anything because I'll be just looking at the graph over there. Oh, I know that at -3 is a minimum, right? Negative 3 as a minimum. All right, second derivative test. We take the second derivative, which was 12x squared plus 24x equal to 0. That's 12x and then x plus 2. And that's x equal to 0 and x equals to negative 2. And those are your inflection points. So now we have 0, 0, and all. Okay, good. So now partition at negative 2, partition at 0, and we have our infinities on each end. Pick points, negative 3, negative 1, positive 1, and do the second derivative test. At negative 3, that's 12 times negative 3 squared, that's going to be positive, plus 24 times negative 3. All right. So 4 times 12, 40. No, 4 times 9 times 12. 9 times 12 is bigger than 6 times 12. So this is going to be positive. Positive, so concave up. Second derivative, negative 1 is 12 times negative 1 squared is just 12. And then you have minus 24. So that's less than 0. There we go, concave down. Oh, you really got that one. And then we have a 1. So that's going to be 12 times 1 squared plus 24 times 1. That's all positive. So concave up. Now I have a lot of stuff here, so I'm going to attempt graphing. And if I fail, right, I'm going to calculate additional points. Now, I didn't calculate the x value for my minimum, right, negative 3. So I'll need that. I need to calculate for my let's go purple. For minimum, I need to calculate y value. So y is f of 3. Was it 3 or negative 3? Negative 3. Minimum is a negative 3. So negative 3. And negative 3 to the 4th plus 4 times negative 3 to the 3. Now, you can punch all of this in the calculator, or you can do this. Negative 3 times negative 3 cubed plus 4 times negative 3 cubed. So this is 4 minus 3. So this is just negative 3 cubed, which is negative 27. All right, good. So let's go. I just used algebra. I factored to compute this. So what do? We have our graph. I have my x-intercepts at 0 and 4, if I remember well. I don't know. It's been like a year ago. Negative 4. So negative 4. Then negative 3. Let's put it here. Negative 3, negative 27. That's negative 4, that's 0. And then I have an inflection point at negative 2. I gotta get its y value. So I have y equals f of negative 2, which is negative 2 to the 4 plus 4 times negative 2 cubed. So negative 2, right, to the 4th, that's going to be a positive 16. And then this is 8 times 4 negative 20 and negative 32. So we have negative 16. So negative 2, negative 16, let's say here, doesn't matter. All right, so the graph. We need to have the graph to be decreasing. We have a minimum. Anytime you have a minimum, you put a little smiley through it, through the point, right? So, because that's a minimum, right? Smiley, and maximum is a frown. So, you put a little smiley through the minimum. And then you just connect all the dots, like in a coloring book, right? You go here, you change the concavity into that one, and then you change concavity again, because concavity changes twice. There we go. And I already graphed this in Desmos, and we have seen it. That's what we have. Right? Cool. When we come back, we are going to do another 2 examples. We'll try to fit something with ln and something with trig. And then, you know, the rest is going to be just endless slaving at home to do these problems, right? These problems are awesome to kill time. Well, carpal tunnel, right? They're amazing. Take long time. So there will be part 2 when we're done.